The first thing I want to do is I want to try to draw the picture. Okay, so when I'm drawing the picture, I'm going to say something along the lines of, we've got a starting point for each person, maybe here and here, starting point right there. And then I've got Bob, and Bob goes the full distance, doesn't he?
Yeah.
So I'm going to call this arrow that I just drew, I'm going to call this distance of Bob. So like D with a little B down below, D sub B, distance of Bob. Does that make sense? And then the other guy, Joe, of course, as you read, he ran out of gas, got tired or whatever, couldn't finish. And so distance of Joe, DJ, is going to be a little bit shorter than distance of Bob, right? How much shorter?
10 miles.
Exactly 10 miles. So I'm going to put that on here too. Oops. So I'm going to say, from here to here is 10 miles. Does that make sense? Okay. So, you can go about this in any ordering that you want. You could try to write your true equation right now, because honestly, your equation to relate all this stuff is really based on the picture. But maybe you don't want to do that right now. Maybe you say, okay, I feel okay about that. I'd like to try to organize things and make my table. Make sense? Maybe we try that. So I will try to make a table here. So over off to the side, I'm going to go Bob and Joe. And I'm going to have a rate and a time. And then the last column is for distance. Okay, so I think the rates are the easier thing to figure out here. Evan, what did you have for the rate of Bob?
Rate of Bob was 18 miles.
Yep, 18 miles per hour. And then Joe was? Okay, so, that's pretty straightforward, right? I mean, it'd be easy to mix those up perhaps, but if you're staying organized with some kind of a table or some other organizational strategy, then you should be able to get those things plugged in where they're supposed to go. The times are more difficult, aren't they? The times come from this. It says, if Bob's finishing time was 1 hour longer than the time that it took Joe to quit. So Bob's time was 1 hour longer than Joe's time to quitting. So these are unknowns, aren't they? This is really the question. So this has to involve a variable. Has to. Who would you want to make, like if we say X or something, what would you make X, Hunter?
On Bob.
Make Bob X?
Oh, no, like just X?
Yeah, just X.
Oh, Joe.
You want Joe to be X. Is that okay with the rest of you guys? It really makes no difference. You could set it up either way, but we'll go with Hunter here and say that Joe is X for his time. Now, who was on the bike for a longer period of time? By how much? 1 hour. And so Bob's time would be? X plus 1. Good. Does that make sense to everybody? If it doesn't seem logical, we need to address it. But if it seems logical, then we can move on. Okay, so then with the distances, you will almost always multiply your rate times your time to get your distance. Okay, it'll be very rare that the distance of each person is just given to you. Okay, so let's multiply. So the distance of Joe would just be 20x. What property do we have to use to get the distance of Bob? You've got to distribute that 18 across both terms. So it would be 18x plus 18 for the distance of Bob. I distributed 18x plus 18. Does that not seem logical?
No, it is. I just thought you were writing it with 18 parentheses.
Oh, no. Just like that. Okay, yes, sir. Yeah, go ahead, Ben.
Well, for the next step,
I haven't got to the next step yet. You want to get to the next step now?
I was saying what I did for the distance.
Before you do that, does anybody have any questions on the organizational stuff with the chart, the table, the multiplying to get the distances? Any questions whatsoever? Okay, so Ben wants to move on to the next step. Let's go. What do you got?
I said that Joe's distance, but I don't know if this is right. I did 20x minus 10.
Well, okay, so remember a true statement always involves an equal sign.
What I'm saying for his distance.
But I get what you're saying. I tried to express Joe's distance somehow. But you said, and I'm not saying whether this is right or wrong. You just said 20x minus 10. And I'm coming back to you saying equals what? Because this true statement must be an equation. It can't just be a floaty expression for whatever, or Joe's distance, or Bob's distance, or who knows what. It has to be an equation where this thing over here equals this thing over here. It's got to be that. So I don't know. So think about that. So the stage we're at here, we're really looking for a true equation, right? A truth about these guys' distances. What do you think?
18x plus 18.
Take it one step back. Just use distance of Bob and distance of Joe.
Alright. The distance of Bob equals the distance of Joe.
Okay. Did I write that down correctly?
Yes.
What do you guys think?
Yeah.
Is that a truth?
True, no, 'cause Joe was too much.
According to my picture right there,
That's correct.
Joe's arrow is shorter than Bob's arrow.
I was thinking
10 plus
minus.
10.
So I don't think that I can write that, Hunter. I mean, seriously, look, the distance of Bob
Yeah.
is truly longer than distance of Joe. That's like saying 20 equals 5. It's got to be a true equation. You've written an equation.
Minus 10.
I think we can fix it. I'd rather do something slightly different. Rocky, what would you say?
Oh, you just said.
Well, all she said, I might not have heard the first part. All she said was minus 10. And I'm just wondering, minus 10 from what? My salary? I'm not very happy about that.
Oh,
Minus 10 from my age? A little happier about that.
add 10.
Add 10 to my age? No, thank you.
Joe's distance.
Oh, to Joe's distance. Do you see my point? Like just shouting out minus 10 plus 10 has no meaning, no relevancy whatsoever. But if you say add 10 to Joe's distance, does that make it true? Let's find out. She's like telling me I need to be 10 years older. I don't like that. Okay, I want to enjoy the next 10 years. Let me fast forward to Christiana. Okay, here we go. I'm being silly. Does that make sense? Is that logical? Or in other words, is that true? Is the distance of Bob the same thing as the distance of Joe plus 10?
Yes.
It is true. Now, there's slight variations on this. You could have some stuff moved around, but it could all come back to this equation. Here are some other variations on this. Couldn't you have said, and I'll erase these in just a second. Couldn't you have said this? Wouldn't this also be a truth? Distance of Bob minus distance of Joe equals
10.
10. Is that not another truth?
Truth.
And that would be just as good as what we came up with. Because isn't it just a slight rearrangement of what we did? That would also work. And then the thing that maybe Christiana was getting at earlier, you could say distance of Bob minus 10 equals distance of Joe. That's another way of putting it. It's another true statement. It looks a little different than what we put, but it's really the same thing, just slightly rearranged, right? You want to see one more? Check this out. I don't know if you like this or not. We'll see. Distance of Bob minus distance of Joe plus 10 equals 0. There's a fourth way to write it, and we probably could somehow come up with a fifth way too, you know. So my point is this. We get very hung up on, I always do it this way. I'm wanting to like release you from those handcuffs of, I always do it this way. I want to make you free to write a truth about the situation. And it could look, I've already showed you 4 different ways. So we don't all have to write the exact same thing as long as what you write is true and helpful, right? Don't start writing about other stuff. As long as you're talking about Joe's and Bob's distances and blah, 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 if you write a truth, you're good. You see how you're free instead of being shackled to, this is how you always do it. I hope you get organized, and then you're free to write something true. We good?
Yeah.
So let's go back to the kind of the original truth that we came up with. We know how to express Bob's distance and Joe's distance. So what I could say then is distance of Bob is 18x plus 18, and that equal distance of Joe, which is 20x, and then plus 10. So would you agree with me that once we get to that point, you guys are all really well equipped to solve that? That's not going to be the hardest thing you do on a question like this, right?
Right.
I hope not, because we practiced this a ton. You've showed that you're pretty good at it. And so let's finish it up real quick. Would you guys subtract 18x from both sides?
Yes.
No.
I'm running out of, well, that is the little one. 20x is bigger than 18x. Yeah, I'm with you. I'm with you on the same wavelength here. I'm gonna not show some steps here because you can see I'm running out of room. So I'm gonna subtract 18x from both sides. So that's gonna give me 18 equals 2x plus 10. Subtract the 10 over. That's gonna give me 8 equals 2x, which will finally give me. Well, divide by 2, you get x equals 4. So again, I'm skipping some of those equality steps because I'm out of room. So x equals 4. What did x stand for?
Distance.
No,
Time.
it stood for a time. What did the question ask for?
Distance.
What was the full distance? So I can figure this out, can I? If time was 4, and I know the two guys' rates, I can figure out the full distance of the ride. So who actually went the whole distance? Bob. So Bob's time was not x, it was x plus 1. You see how the table really helps you finish this? It's really a good organizational tool. So for how many hours did Bob ride his bike?
5.
5 hours. That's a long time on a bike, right? And what's his average rate?
Oh my God.
18 miles per hour. So how do we figure out a distance given a time and a rate? 18 times 5. So I would come back up here to finish this maybe and say the full distance of the ride was an average rate of 18 times a time of 5. What's 18 times 5?
90.
It's a long ride, isn't it? 90, no, 90 miles. It was 5 hours. 5 hours, 90 miles. Okay? So that'd be the full. So if we can get past how long Bob was riding his bike.
This doesn't even make any sense.
What? All of it makes no
No,
sense.
it doesn't make sense.
Okay. What makes no sense?
Oh, wait.
Okay, think about it. Like, if you're going 18 miles an hour and you're trying for 90 miles, it's not going to take 5 hours, is it?
Yes. It is.
It doesn't seem like it. I don't know.
Think about this, Christiana.
It's okay.
So I want you to think about this. 18 miles per hour. Think about what that unit means. Doesn't that, if 18 miles per hour, doesn't that mean for every hour you spend, you will actually move 18 miles?
Oh, I think I was confused. Because, like, I was thinking about, like, on the car, like, going 18 miles per hour.
Yep.
That's how fast I go in my neighborhood, and there's no way I'd get 90 miles.
In 5 hours? Yes, you would.
Okay.
Do 90 divided by 18.
Yes, I got that.
Think about it like this, Christiana.
I
No,
guess the math makes sense.
no, think about this. Fort Collins is roughly 90 miles from here. You know where Fort Collins is?
Oh, okay.
Northern Colorado. It's 90 miles. No, guys, listen. I want to help alleviate the confusion because it's legitimate what you're saying. It's just about perception. So Fort Collins is roughly 90 miles from here. If I get on I-25 and I drive towards Fort Collins, I can get there in about an hour, 25, hour and a half maybe, something like that. How fast am I driving on I-25?
It's like 70 miles.
75, 80 miles an hour, right? Can you imagine me getting on I-25 and going 18? How long do you think it'd take me to get to Fort Collins? About 5 hours.
And you'd probably calm down.
And people would be really mad at me. So my stress level would be here and it would take me forever, so I'd be getting a lot of extra stress. You get my point?
Yeah.
You said the math makes sense. If the math makes sense, it makes sense. Right? Okay, good question for sure. Let's see where we are at. Okay, let me just do a little.
Do we need an equation?
Oh yeah, we'll eventually need an equation, but
No, I mean like the letter ones.
especially not for these really.
Okay.
Not really. So let's read together. This says Dan needs 30 gallons of a 20% paint thinner solution. So he needs like a solution, which is just like, maybe a liquid mixture. He wants it to be 20% paint thinner. If he has a container of 5% paint thinner solution and another container of 50% paint thinner solution, how many gallons of each solution must he mix together? So in other words, he's got a bucket of 5%, another bucket of 50%. He wants to mix the two together to blend them so that the final mixture in his desired container is 20%. So you've seen this before, correct?
Yep.
Okay, so the way we set these up in the mixture problem is with a little table. So we're not going to draw pictures of this necessarily. It doesn't work the same as the distance, rate, and time problems. So I'm going to make a little chart here. So the way we typically labeled these is we said weak and strong. Weak and strong. Okay. So we are going to have an amount, and we're going to have a concentration, and we're going to have a final column. That's how we've more or less labeled all these. So amount, concentration, and final. Okay, so like I'm a big fan of, as we're trying to organize these things, you're reading it, you're marking your question up, you're identifying key things. I like to fill out the chart with the easiest stuff first. So what do you think is going to be the easiest stuff to plug into the table? Say again?
Concentration.
Concentrations are pretty clearly spelled out, aren't they? What is the concentration of the weak amount? 0.05, yeah, 5%. And then how about the strong? 0.5, yep. Okay, so then the amounts are always a little tougher. What amount does this person does Dan want to end up with in the very end? He wants 30 gallons. So does that mean he needs 30 gallons of each? Because if he did, he would actually end up with 60 gallons. He only wants 30. So the amounts are definitely unknowns, aren't they?
Yeah.
So unknowns always involve some kind of a variable. So we would just want to make one of them an x. Which one do you want to make an x?
Weak.
Weak is going to be x then. That's fine. Actually makes no difference. I'm going to go with what he said. If the weak is going to be x gallons, and we want a total of 30, how much would the strong have to be?
30 minus x.
30 minus x, right? Be 30, like the amount that we want, minus however much we just put in. Does that make sense? You're giving me a funny look. Okay. So let's think about it like this. We got a little more filling out to do here. 30 minus x is correct there. Amelia, if I told you that I wanted 30 gallons of a solution and I said, you know what, I've already put 12 gallons in, how much extra do I have to put in to get to 30?
18.
Isn't that 30 minus 12?
Yeah.
Does that make sense?
Oh, okay.
So if the amount that I put in was an unknown, right? So I put in X gallons, that means my final bucket here already has X gallons in it.
Okay.
So how much extra do I need to put in? Well, X less than 30.
Okay.
Make sense?
Yeah.
Okay. All right, so then what we're going to do is we're going to add one more row to the bottom of this. And the bottom of this is simply going to be what we want in the end. So what is our final amount? What do we want to finish with? 30. What concentration do we want to finish with? 20%, yeah, so 0.2. And then what is the final column comes from multiplying the amount times the concentration. So for my final weak, it's going to be 0.05x. For my final strong, what property am I going to have to use? Yep, so I'm going to distribute this. What is 0.5 times 30? 15. So it'd be 15 minus 0.5x. And then 30 times 0.2 is 6. So we just multiply the amount times the concentration to get the final. All right, so then what we do with this then is we take our final and we make our equation from that final column. We make our equation there. So this would end up giving us 0.05x plus 15 minus 0.5x equals 6. Like I said with the previous question, I really feel like if we can get organized with a table like that, maybe a picture like the distance equals rate like we just did times time, like we just did a second ago, if we can get to the equation, you're all really good at solving equations. That's not going to be the hard part. So don't get too stressed about that. You want to do it well, but it's the organizational piece. Making the chart, drawing the picture if needed, that's going to be the difference between success and failure. So I'll quietly solve this up here. I know you guys can do this on your own, so I'll just work quietly up here. I will be skipping a few steps because of space. Is X 20? So for a concluding statement here, what we would say is we need 20 gallons of which solution?
A week.
The weak one, yep, of 5%. And how many gallons do we need of the strong? 10, right? You're just doing 30 minus 20 to get that 10. So 10 gallons of the 20%. Okay, so there it is. And so graphing using the rectangular coordinate system is where this starts. So I just want to make sure we all know what the parts are so we can refer to them. Do you guys know what we call this line right here? X-axis, yep. That is typically known as the x-axis. We can relabel it as whatever we want, but in general, it's assumed that that's the x-axis. And then this one right here is the y-axis. Yes, that is correct. Okay, some other things that you might be a little bit less familiar with. Do you guys know what this little point is right here in the middle where the x-axis and the y-axis join? That is called the origin, yep. So we want to be really clear about that terminology. The origin is also known as 0, 0. Those are the coordinates for the origin. We'll get into those coordinates here in a second. And then the other thing I want you guys to know how to label here, know what they are the different quadrants. The x-axis and the y-axis divide this graph into 4 separate quadrants. Rocky, what do you think those quadrants would be?
It forms a C, so quadrant 1 is the top, right?
Yeah, quadrant 1 is this one.
And then the left of that is the 2,
Yeah,
and then below that is 3. To the right of that is 4.
that is correct. So we use those Roman numerals. Quadrants 1, 2, 3, and 4. Starts in the upper right, goes counterclockwise. Rocky says it makes sort of a C. That's also a good way of putting it. But we want to know what those quadrants are. Well, I think we'll practice that here in just a second. The assumption here is that you've seen this before, so we'll see how we do. This says plot each point and state which quadrant, state the quadrant in which each point lies, or which the point lies. That's a little bit of a typo there. State the quadrant in which the point lies. Okay, so what does 3, 0 mean? What,
On the y-axis.
okay, yeah, so what's when you see these coordinate points, it's something, something, always. What is it?
X, Y.
That's right, it goes in alphabetical order, right? X, Y, Z, so it goes X, Y. And so that first point, the 3, that means that the x coordinate is 3. So it's actually going to be on the x-axis, right? So that means, like on our graph here, we're going to go right 3
That's what I meant.
and up 0, right? So right 3, up 0. So that point, we usually represent the point with just a dot.
What quadrant would that be in?
It's not in a quadrant. Great question. It's on the x-axis. It's not in a quadrant.
So what would we say for that? Just no quadrant?
Yeah, none.
On.
So we'll say no quadrant on that one. The point -2, 5. Remember, x is the first number, y is the second number. So remember, we always start at the origin. So if I was going to try to graph this, what I would do is I would say I'm going to go left 2. -2 means go left 2. So left 2. And then up 5. So up 1, 2, 3, 4, 5, I think? Yeah. So that point up there would be -2, 5. Now, which quadrant is that one in?
2.
Quadrant 2, so Roman numeral 2 for that one. Okay, then the other one, the letter C, 1/2, -4. So the 1/2 stands for which coordinate?
X.
So 1/2 means go which direction?
Right.
Right half. So this is going to be a little tougher to graph. So 1/2, -4. I will do my best. Here we go. So 1/2 means I'm going to go right 1/2. I'm doing this in orange. Can you see it?
No.
My little orange line right there. It's hard to see, I agree. But then we're going to go down 4, right? Because -4 means down 4 in the y direction. So down 1, 2, 3, 4. And then that point would be right about there. Which quadrant is that in? Quadrant 4. So Roman numeral 4, IV. Why don't you guys try the last one on your own? Ready, go. If you haven't already done so. I see a lot of you guys are noteless. You get on Schoology. So a lot of you are noted, I guess. Get on Schoology, print your notes out. I will say to basically to your benefit, this section, being about lines and graphing lines and things like that, is very graphic dependent. Very graphic dependent, and so for you to be able to like sketch out some picture and then try to answer the question, like we're just have the picture in front of us, it's going to be very difficult for you. So I'd encourage you, in the strongest possible terms, print the notes out and bring them. Question?
How do you prefer us to write it? Do you want us to put a line or like?
Well, you just say no quadrant. Yeah, just say no quadrant there. Yeah, Ellie, go ahead.
Do we have to do it in Roman numerals?
Yes,
Why?
that's official math lingo.
No.
And this is an official math class. So we will follow. And you know, part of the point with something like that. Oh, -2, -4. Sam, which direction did you go first?
Left.
How far?
2.
Left 2. I agree. So I'm going to start at the origin, and I'm going left 2. Doing this in blue here. And then you went? Down 4. Good. So down 1, 2, 3, 4. So we've got that point right there for -2, -4. And what quadrant is that in?
3.
Roman numeral 3. Yep, so 1, 2, 3, Roman numeral. That's our quadrant there. So the point here is, are you solid with this? You know what the x and the y-axis, the origin, the quadrants, how to get the points all set? Okay, awesome. Okay, so here we go. Use the graph below to answer the following questions. Look at the graph here. Notice that the x-axis has been relabeled for this particular situation. What is the x-axis describing? Do you see it right here? I'll try to underline it. Time in minutes. What is the y-axis describing?
People.
Yep, size of audience. Number of people. Sure. Okay, so keep that in mind. You got this little graph right here. It says, question A, how many people were in the audience 80 minutes before... hang on.
Doesn't make sense.
Zero.
Yeah, it doesn't make sense.
0 people.
Hold on. Hold on.
Well, it doesn't make sense.
I said, hold on. I think that's a little typo. I think it should say after. Sorry. Apologize for the typo here. This should say after. That changes things a little bit. So let's relook at it. So how many people were in the audience 80 minutes after taping began? What do you think, Ellie?
100.
So do you see what she's doing? She's identified 80 minutes over here.
No.
And didn't you just like look up here to see where the graph was?
Yeah.
It's right there. And then to see how high that is, don't you just trace back over to the y-axis?
Yep.
100 people. Does that make sense? So this is talking about how to read a graph. I'm not going to assume that we're experts at this. We might be, and that's great if we are. I'm not going to assume anything. And then part B, at what time before taping were there exactly 150 people in the audience? So you got to read the graph a little bit backwards here. Evan, what do you think, buddy?
10 minutes before.
So before taping, so we're talking about over here, right? And so this is kind of going the other way. We see 150 people. We trace this over to the graph, and you actually trace it down. -10 means, like he said, 10 minutes before. And so the answer to this would be, please don't pack up yet. We still got plenty of time. 10 minutes, right? So 10 minutes before taping, there were already 150 people in the audience. So we just want to learn how to read a graph like this and be able to do it accurately. Does that make sense? Okay. Awesome. So let's go back to that other question that we skipping for on something like this is x comma y. Okay, so let's just run through these. What do you guys think? Just raise your hand if you think you know the coordinates for point A. What do you think, Rocky?
Parentheses 2, 3.
2, 3. We agree with that?
Yes.
A is 2, 3. Okay. How about B, Alec? 0, 4. Agreed. Very good. And finally, we have C here. Ellie, what do you got?
-3, 2.
-3, 2. Very good. Next up is D. Jake.
-3, -3.
Yep. -3, -3. Very good. Danny, how about E?
0, -4.5.
Yeah, I agree. It's kind of in between the -4 and the -5, isn't it? Yeah. So 0, -4.5, I think makes sense. And then Ben, how about F?
That is 1,
Negative 2.5?
Yep, I think kind of similar to Danny's, it's kind of in between there, isn't it? So negative 2.5 seems reasonable. Chapter 3, off to a good start.